Assalamualaikum and hi everyone. I am Nabila and we are from Group 9. In this video, we will presenting our finding for assignment 2. Our project is based on a case study for InnoTech Manufacturing Ltd, a company that produces HVAC system. InnoTech is planning to expand and our job was to analyze their cost, budget, investment and help them to make better decision. Each of our group members will explain the key selection of the report, which include cost classification, budgeting, break-even analysis, capital investment evaluation, inventory control, key performance indicator, and decision-making tools.
Good day everyone, I'm Ferry Parang, and in this section we look at how InnoTech classifies its costs into direct and indirect categories, something that is essential for accurate pricings and project profitability. Starting with direct costs, these are expenses that can be traced directly to a specific product or job. For InnoTech, that includes raw material, compressors, copper tubing, direct labor such as assembly technicians, engineers, packaging for specific hatchback models, and transportation costs tied to customer deliveries. These are all traceable and specific to job. On the other hand, indirect costs are shared across the organizations and not easily assigned to a single product. This includes costs like factory rent, administrative staff salaries, quality assurance, utilities insurance, IT support, and R&D expenses. Understanding these distinctions is crucial for InnoTech, especially when allocating costs properly. While direct costs can go straight to the job, indirect costs needs to be distributed fairly using costing technique like activity-based costing, which we'll discuss later. Ultimately, having a clear separation between direct and indirect costs helps the company make smarter, data-driven decisions, especially when it comes to setting prices and managing overhead.
Now let's move into how different costs behave at InnoTech as production level change. First, we have fixed costs. These remain unchanged no matter how many HVAC units are produced. For example, the factory lease, administrative salaries, and depreciations total over 200,000 ringgit monthly. These are predictable and stable costs. Next are variable costs, which increase with each unit produced. This includes raw materials, labor, logistics, and testing supplies. For every HVAC unit, InnoTech spends about 1,470 ringgit just in for variable costs alone. Then there are mixed costs, a combination of both fixed and variable components. For instance, maintenance may have a base fee of 5,000 ringgit, but additional charges are based on machine hours. Similarly, supervisors' bonuses may depend on production output. Understanding these categories help InnoTech plan for expansion by focusing how total costs will shift at different production volumes. A fixed cost spread out over more units, while variable and mixed costs scale with growth. This distinction is key in break-even analysis and capacity planning, topics we'll explore in the upcoming slides. Now let's analyze how InnoTech's costs behave at different production levels, a crucial part of expansion planning. This cost function is simple but powerful. Total cost equal to fixed cost plus variable cost times with number of units. At InnoTech, monthly fixed costs are 6,500 ringgit, and variable costs are 1,470 ringgit per HVAC unit. We can see in the table that total cost increase as unit increase, but the average cost per unit drops significantly from 5,600 ringgit at 50 units to just 2,296 at 250 units. This is a clear sign of economies of scale. The break-even point is also critical. With a selling price of 3,500 ringgit per unit and a contribution margins of 2,030 ringgit, InnoTech needs to sell around 102 units per month to cover all costs and start making a profit. This cost behavior analysis supports pricing strategies, investment decisions, and resource planning, especially within a relevant production range of 50 to 250 units. Outside the range, costs may behave differently. By understanding this, InnoTech can scale operations confidently and make data-driven decisions. Now let's look at the costing techniques used at InnoTech and why the company applies a hybrid approach. First, we consider three main costing methods. Job order costings is ideal for InnoTech's custom HVAC units. It tracks direct costs like materials and labor per job. Process costing wasn't suitable because InnoTech doesn't mass produce identical items. Activity-based costing (ABC) allows us to allocate overhead based on real activities like machine setups and quality checks. So what's the solutions? A hybrid method that combines jobs order costing with ABC. Job order tracks the unique cost of each project. ABC ensures that overhead like engineering support and testing are fairly distributed, rather than using simple estimates based on labor hours. For examples, in a recent project for Memorial Hospital, the cost per unit was calculated as 10,216 ringgit using the hybrid method. If we had used traditional costing, we have under-allocated by 768 ringgit, risking underpricings and inaccurate profit margins. This hybrid system gives InnoTech accurate, relevant, and actionable cost data critical for budgeting, pricings, and staying competitive in a specialized hatchback market. To justify the use of a hybrid costing system at InnoTech, we need to consider both operational reality and strategic value. Starting with job order costing, it's clear that InnoTech works on a highly customized hatchback unit. Each job may vary in design, materials, or complexity. These methods allow cost tracking on per project basis, supporting accurate billing, profitability analysis, and even after-sales decisions. However, InnoTech's operations do also involve in high and diverse overheads, like engineering designs, quality assurance, and machine setups. These costs don't scale neatly with labor hours or unit count, so using traditional allocations methods would distort costs. That's where activity-based costings (ABC) comes in. It assigns overhead based on actual activities consumption. A complex hospital project that demands more engineering times get more overhead assigned to it, while simple jobs don't get unfairly burdened, and this makes costing far more accurate. Strategically, the hybrid systems empowers InnoTech with better pricings, more accurate forecasts, and smarter decision making, and it ensures every bid is competitive but still profitable. It also strengthens budgeting and performance evaluations by comparing expected and actual job costs, critical in high stakes markets like healthcare and green constructions. And in conclusion, hybrid costings isn't just technically appropriate, it's a strategic advantage that supports InnoTech's goals for expansions, profitability, and long-term sustainability. Let's see how the hybrid costing method works in action using real job custom hatchback system for Memorial Hospital. First, we calculate the direct cost using job order costing. Total direct materials comes to 19,000 ringgit, including specialized compressor filtration systems and copier tubing. Labor was 5,600 ringgit, covering engineering design, assembly, testing, and installation support. Altogether, that's 24,600 ringgit in direct costs. Next, we apply activity-based costings, ABC, to overheads. InnoTech allocated 6,048 ringgit in overhead based on specific activities: machine setup, engineering support, quality testings, and production supervisions. This gives us a total job cost of 30,648 ringgit or 10,216 per unit for the 3-unit project. But here's the key insight. If we use a traditional method based only on labor hours, we'd allocate just 5,280 ringgit in overhead. That's 768 less, leading to undercosting and potential underpricings of the job. This example proves why the hybrid methods is essential for InnoTech Customs' complex projects. It reflects the true cost of resources used and protects profitability.
Good day everyone, my name is Shelly Maijin. In this section, I'll present the operating budget for InnoTech Manufacturing proposed expansion. The project revenue for the first year is 1.2 million ringgit based on anticipated demand growth in the HVAC industry, especially for hospitals and green certified buildings. Operating costs are expected to be 750,000 ringgit, covering direct labor, materials, and overhead. Additionally, there's a depreciation cost of 60,000 ringgit per year for robotic welding equipment, which was capitalized at 300,000 ringgit and depreciated over 5 years. After all expenses, the net operating income stands at 390,000 ringgit. This suggests that expansions could be financially viable. Moving on to this slide, the budget was built on several key forecasting assumptions. First, revenue is expected to grow at a steady rate of 5 to 6% annually. This is driven by rising demands and operational improvement. The robotic automation is projected to increase production capacity by up to 25%, while also controlling units cost due to economies of scale. When we look at the 5-year financial projection, net income grows consistently from 390,000 ringgit in 2025 to nearly 500,000 ringgit in 2029. These growth trends confirm that the investment not only improve efficiency but also support long-term profitability. Next, I'll explain the break-even analysis, which just determines how many Havoc units must be sold annually to avoid losses. Fixed costs, including depreciation and overhead, are estimated at 300,000 ringgit. Each Havoc unit is sold for 5,000 and has a variable cost of 3,500 ringgit. That gives us a contribution margin of 1,500 ringgit per unit. Using the break-even formula, the company must sell 200 units per year just to cover all fixed and variable costs. Selling more than 200 units shift the company into profit territory. The break-even chart clearly shows the revenue and total loss cost line intersecting at 200 units. Beyond this point, every additional unit sold at 1,500 ringgit directly to profit. This analysis is not just theoretical, it plays a critical role in planning production targets, setting sales goals, and assessing investment risks. It's also helped the management understand how pricing, material cost, and labor efficiency impact profitability. In summary, break-even analysis ensure the expansion is not only feasible but also strategically sound. Thank you.
Good day everyone. I'll be presenting two key sections from our operational evolution for InnoTech, capital investment and inventory control. Starting with capital investment, InnoTech is considering purchasing robotic welding equipment to enhance production capabilities. The equipment costs Rm 300,000 ringgit and is expected to generate Rm 90,000 ringgit in savings annually over a 5-year period. To evaluate this decision, we use two standard financial tools: net present value (NPV) and internal rate of return (IRR). The NPV came out to Rm 41,172 ringgit, which is positive. This means the investment is expected to return more value than it costs over its lifetime. The IRR is approximately 15.2%, which is well above the company's required return of 10%. This result indicate a strong financial case for the purchase. Beyond that, the robotic welder align with InnoTech's goal of automation, consistency, and long-term cost efficiency. In short, both financially and operationally, this investment is viable and recommended. Now let's move to inventory and cost control. InnoTech manages four primary types of inventory: raw material such as steel and motors, work in process (WIP), HVAC unit in various assembly stages, MRO supplies, which are tools and items needed for maintenance, and finished goods, the completed HVAC unit ready for delivery. To control this efficiently, we propose four inventory management methods. First, ABC analysis, which help us prioritize high-value items for tighter control. Second, just-in-time JIT inventory, which minimize holding costs by receiving materials only as needed. Third, barcode and RFID tracking, allowing real-time inventory updates and minimizing manual errors. Lastly, cycle counting, which improve accuracy without requiring full inventory shutdowns. These strategies not only reduce waste and overstocking, but they also support more accurate costing, better budgeting, and leaner operations. Overall, effective inventory control directly impacts financially performance by improving efficiency, lowering costs, and ensuring accurate product costing. That concludes my section. Thank you.
Good day everyone, I'm Max Lorenzo and today I'll be presenting on performance measurement and key performance indicators or KPIs. So what is KPI? It's a measurable value that shows how effectively a company achieving its critical business objective. KPIs help track progress, identify problems, and make data-driven decisions. So let's start with the KPIs tracked by InnoTech. Cost per unit or CPU is a key financial metric that shows how much it costs to produce a single HVAC unit. This includes direct materials, direct labor, and overheads allocated using activity-based costing. So from the sample calculation for producing 3 custom units for a hospital, it results in direct materials 19,000 ringgit, direct labor 5,600, activity-based overhead 6,048 ringgit, total job cost 30,000, and divided by 3, it costs in 10,216 ringgit per unit. So monitoring CPU helps the company evaluate job profitability, detect inefficiencies in specific process, and make informed pricing decisions. So next is defect rate. Uh, what is defect rate? It tracks the percentage of defective units out of total production. For example, if 2 units out of 100 are faulty, so the defect rate is to 2%. This metric helps the company reduce rework costs, maintain product reliability, and meet the strict quality requirements of sectors like healthcare. Now, let's discuss the financial impact of these KPIs and their relevance to engineering operations. So, from a financial standpoint, KPIs offer several strategic benefits. First is cost reduction, lower defect rates, and improved process control, reduce waste and rework, thus cutting operational costs. Next is increased profit margins. It means that higher production efficiency allows more units to be produced without raising fixed costs, spreading overhead, and improving profitability. Better cash flow, accurate inventory and cost tracking mean fewer resources are tied up in unsold stock, which means that it boosts the liquidity. Customer satisfaction and retention. Consistently low defect rates and on-time delivery improve client trust, leading to repeat business and long-term contract. Next is labor cost efficiency. So when employee productivity improve, the cost per unit of labor goes down. Next is these KPIs are also highly relevant to engineering operations. First is cost control. So engineers in InnoTech use CPU data to identify areas where material or labor usage can be optimized. Production efficiency. Downtime metrics help engineers assess and improve equipment reliability and workflow. Quality assurance. Defect tracking reveals design flaws or assembly issues, prompting faster improvement. And maintenance, downtime percentage, inform preventive maintenance schedules to reduce unplanned stops. And lastly, employee performance. So by linking output and quality to labor input, engineering managers can improve training and optimize team allocation. So in conclusion, KPIs at InnoTech are not just numbers. They are essential decision-making tools that connect financial health with engineering performance. So by tracking and analyzing these indicators, the company ensures sustainable growth, product excellence, and operational success during and beyond its expansion. Now moving on to project cost management. So what is project cost management? It's a process of planning, estimating, budgeting, monitoring, and controlling costs to ensure a project is completed within its approved budget. So InnoTech uses several cost monitoring techniques. First is budget tracking, where it compares actual expenses against planned allocation for equipment, labor, and materials. So this enables the team to detect overspending early and adjust procurement for schedules accordingly. Next is Earned Value Management, EVM. It provides a more advanced view by linking cost, schedule, and scope. For example, if installation is 60% complete but 80% of the budget has been used, EVM signals cost overrun. This allows management to take immediate corrective action, like optimizing labor use or delaying non-critical tasks. Next is cash flow monitoring. It's used to ensure the project maintains enough liquidity. This is especially important for stage payments on robotic welding equipment or supplier contracts. So in terms of cost control tools, InnoTech integrates with Gantt charts to visualize the project timeline and identify delays. Dashboards using Power BI or Excel to display KPIs like CPU and defect rates in real time, and Excel trackers to log and analyze costs, productivity, and material usage down to the job level. So these tools are fully applied across the expansion lifecycle. During procurement, dashboards track delivery time and contract costs. During installation, EVM detects any budget and schedule variance. And during testing, dashboards link quality metrics like defect rates to financial data, highlighting the cost of rework or wasted materials.
One of the most important parts of our report was helping InnoTech decide whether to continue producing a company in-house or to outsource it to a supplier. First, we did a cost-benefit analysis. In-house production costs 400,000 per year. It offers better quality control, but it's more expensive and harder to scale. Outsourcing is cheaper, only 350,000, but comes with some risks like possible delay or lower quality. To measure those risks, we use a decision tree and calculate the expected monetary value or EMV. We assume there's a 70% chance the supplier will perform well, saving 50,000. But if performance is poor, which we estimate at 30%, it could cost the company 30,000. After calculating EMV, outsourcing gave a positive expected value of 26,000, while in-house production had no extra gain. So based on our analysis, we recommend outsourcing the component, but only if InnoTech manage the risk properly, like testing the supplier first and using a strong contract with clear quality standards. To sum everything up, our group analyzed InnoTech expansion plan from different angles: cost, budget, break-even, capital investment, inventory, KPIs, and decision-making tools. We found that the expansion is financially possible and can help the company grow as long as they manage costs and risk carefully. We also believe that outsourcing the component is a smart decision as long as it's done with a proper planning and supply monitoring. So, our final recommendation is to go ahead with the expansion, implement the strategy we proposed, and continue tracking performance to support sustainable growth.